Good morning, good afternoon, or good evening, and welcome to today's DevOps.com program, brought to you by Techstrong, AWS, and Snyk. My name is Cody J. Brown, host of Techstrong Learning, and we have an exciting presentation ahead. First, I just need to cover a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, maybe you want to rewatch, or maybe just share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. Now, that's also where you'll find the chat tab, and that's where we want you to get to know your fellow audience members. Maybe just let us know from where you're tuning in. And of course, before we close, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So our topic is detecting infrastructure drift in your AWS environment with Snyk. And I'm joined today by Stefan Jordan, Senior Product Manager at Snyk. Stefan, thank you so much for being with me. I'm going to let you run with it from here.
Thank you. Thank you, Cody. So let me share my screen so you can have slides. All right. So everything seems okay. All right. So hi, everyone. Welcome to this webinar, kindly hosted by DevSecOps.com, sorry, and for AWS. We were going to talk about infrastructure as code, DevSecOps, infrastructure drift. That's the core of this today's topic on the webinar. And my name is Stefan. I'm a product manager at Snyk on everything related to IAC and cloud, where our goal is to empower developers to take secure ownership of their cloud infrastructures. So it's fully aligned for this webinar. So let's get started. In this webinar, I'll briefly define what is infrastructure drift and what we learned along the way around the different drifts that we found. And after this, the second part of the webinar will be live examples of how things can drift, resources, services, and with the different type of drifts, and how it looks like to detect that drift and to report it in developer terms for us infrastructure developers. So that's the agenda for today. I see infrastructure as code and developers. It's not a secret for anyone. Cloud automation is a hot topic. More and more developers are integrating a lot of tools and different solutions around infrastructure as code with all the best practices that go with it, and with the goal of trying to avoid misconfigurations, those misconfigurations often leading to potential security disasters, etc. So, speaking of developers, it's also become very common to see developers build and deploy and run their own service in the cloud providers, and that's definitely for the better. I'm one. So the truth is still that a lot of the cloud resources are living outside that automated configuration. And it can cause a lot of pain, especially on the security side. So that's what we call drift, this pain. And detecting it means basically gaining visibility of what's living outside of your infrastructure as code IAC configuration. That's the short version. Now, the TLDR, if you just joined and you have like just 3 minutes late, and or you can stay, the TLDR, if you have only one thing to remember from this webinar, it's that almost everyone is experiencing infrastructure drift at some point with different cloud accounts and different infrastructure tools, and the drifts can have major consequences on the infrastructures, especially on the security side. That's the reason why, in the end, we built Snyk IC and Snyk Cloud. So we had to come up with a definition. Everybody has a different definition for infrastructure drift. Ours is the most simple that we could find, and that englobes a lot of different cases. What's a drift, infrastructure drift for us? It's anything that happens when the reality and the expectations don't match. Basically, a synonym for it is, oh my God, things went wrong and they should not have gone wrong. So that's anything that can go wrong in this space. We'll give a lot of examples soon, so you can have concrete examples of things gone wrong with automation, IAC, and different tools. I also know that it's quite an advanced topic. I will try to give quickly enough context about IAC, the ecosystem, the problem we're solving, and why it ends up making sense. So just to be sure everyone is updated with IAC, to deploy a cloud resource on the cloud provider like AWS, you can declare it as code. You literally declare volumes, firewalls, VMs, users, access rights, anything in code. And example tools that do this very well, it's CloudFormation for AWS, or Terraform by HashiCorp for different cloud providers. And once you got this intention written in code, the infrastructure as code, then the tool you use converts that intention into actionable API requests. For the demos we're going to have today, it's on AWS. Then the resource is live on the cloud account. That's how you go from expectation to reality. And that's repeatable. That's the beauty of it. And that's also why Snyk IAC, the product Snyk IAC, scans that code to report misconfigurations as early as possible. It means it's integrated in the IDE, in the terminal for developers, and you get that feedback as soon as possible. So that's the IAC 101 context. Now for the drift 101 context. When the resource that was deployed on the live account don't match the expectations, you have a diff. And that diff basically is the drift. And you can have many types of drifts and diffs. So what can be the different causes and types of drifts? There are many. But I will just briefly mention the major ones. In this case, the most common drift is the manual changes made directly on the AWS console. Sure, it's a bad practice, but many of us still do changes on the AWS console. And in this case, this is very often what we call an unmanaged resource drift. It's just, it should have been managed by IAC, but it's not. So that's one first example of something that went wrong because it's still living and it's never picked up by your IAC security analysis tool. Another common example is microservices, lambdas, scripts that are authenticated. So it can be anything from, I don't know, a nightly script that snapshots some EBS volumes, scans resources for specific tags or the absence of a specific tag, etc., and does an action after it. Lambdas can do this for very valid reasons for applications, etc. Microservices, same way, as long as it's authenticated with rights to do thing, then it can create or modify other things. And if it's not reported, then you might be in trouble very quickly. Alternative reasons to have changes, diffs, drifts, it's that maybe this team is working with a different tool, and then the tool you're using is not necessarily compatible. So you may have one tool to aggregate all the needs, or it just can't be used because we mentioned Terraform earlier. Maybe this new service by AWS is not yet implemented in the Terraform provider, and then you just need to use another tool, CloudFormation, for example. So there are many reasons why you could have managed resources drifts, unmanaged resources, just standalone resources that should have been under control and are not. And we'll see that it's even worse because both can interact together and have an impact on resources that should not have been impacted. The common point between all those examples is really that we are in an authenticated ecosystem. Things are authenticated against the APIs and can have an impact and are basically the sources of drift, the causes of drift. So why is it important? Could be no big deal. We could just don't care about those changes. Maybe it can just leave where it is, and it's not a problem. The reality is that misconfigurations often lead to security issues, and from an infrastructure developer perspective, you can't know about those issues if they are not into code. So you have probably misconfigured resources that have security issues and you don't even know about them. You are in the dark. In this slide, so I think it's the NSA 1.5 years ago, they released this slide and they said that poor access control and misconfigurations are top issues for everybody. I also found, like recently, that 2 years ago, cloud misconfiguration breaches costed $5 trillion in breaches. That's incredible. And just today, I just read this morning actually that McAfee released that 99% of all the misconfigurations in public clouds actually go unreported. That's how bad misconfigurations for things that are not under control, not seen, not reported are. So that's why basically at Snyk, we want to help developers, as I said earlier, to take secure ownership of the cloud infrastructures, but we also want to let them know about all the unknown stuff running on the cloud provider, on the cloud providers. Because if you don't know what's running, basically it's impossible to secure it from an infrastructure developer perspective. So before jumping into the real life examples with demos, I would like to share some major topics, real life example that we experienced either firsthand ourselves or with customers or partners. And examples include, they are not always the simple, oh yeah, we had a misconfiguration, we never fixed it, and we got a breach. Sometimes, most of the times actually, people are actually well tooled and they do things quite correctly and they think they are protected enough. So those three areas I'm going to mention quickly are cases where protection looked enough and was not enough actually. So the first one, for example, is that deployment pipeline, infrastructure deployment pipelines are just that, deployment pipelines. They are not necessarily supposed to be run every 5 seconds. So what happens when someone changes something manually? Obviously, the deployment tool can revert that change. But if that tool is, that pipeline is not triggered by a pull request, a merge or something, or every 5 minutes, what happens? Well, it's never reverted. So you stay with that problem while you can run your IAC analysis tool every second if you want. You will always get you will always get a good feedback about the security of your cloud account while it's actually not. So that's one case, and I will dig deeper in the next examples after this slide. The second one is obviously the manually created resources. They are not under control, nothing new here. But what can be new is that something that is created manually now, day one, probably has insecure defaults from a IAC security misconfiguration perspective. An example is probably all the wizards that we're going to use on cloud providers' accounts won't bother you with hundreds of settings by default. So probably you will do this later. Encryption, KMS keys, etc. It's not a requirement to get started just launching a simple Ubuntu VM, for example. So it's the same for many services. So that thing that is not a problem day one maybe can become a problem later because it's never imported back to the IAC. So you can never have that feedback from, once again, from a developer perspective. You're a developer, you're using a developer tool, you are living in your IDE, and what you want is feedback from, oh, I did not enable ABS encryption. Oh, I left this specific security group open. Oh, I did not activate this on S3, etc., etc. What if someone in this manually created scenario, what if you have your API gateway entirely into Terraform and you just simply add manually a path? It will never get picked up. It's a deployment tool, not a monitoring tool that will detect things around. So in this case, maybe that path was misconfigured and you will never know about it. So that's why Drift, in this case, for the manually created resources over time, is important. If it's never imported into IAC, you can never know about it. The last big family of problems with Drift you can meet is everything around the scope of impact of a change that is not directly on your managed resources using the IAC, but larger, like something else somewhere else in the cloud account actually has an impact on this very well configured resource. So you can have your IAM user perfectly well configured, but if someone changes something somewhere else and you can't know about it because it's not in IAC, then it may have an impact. It can be someone else opening a port somewhere else that give access to what was previously completely hidden from the public internet, that type of thing. So having cloud context for local analysis and having the reality of the cloud accounts for the context of an infrastructure developer in the terminal, in the code directly in the IDE, that's super important to have that feedback as early as possible, not once it's too late and deployed. That's basically what I wanted to share for the main speaking part. So now, stories and examples, concrete examples. What we're gonna do today is live examples using simple Terraform code and simple examples. They are all based on live, real life examples, but we don't have time to wait for like long deployments, etc. So I deliberately choose simpler and quicker examples, so we don't wait like 5 minutes waiting time for things to deploy, etc. So yeah, I'm definitely happy to answer more concrete questions after the demos, if you are interested by what you see and you have maybe your own examples. So in this case, So I have probably, like, I don't remember, maybe 4 or 5 examples, depending on the time we have and the interactions we have. The first one is very close to us, actually. At the beginning of the pandemic, this team we were working with just ended up at home, and there was a lot of problems to get access to the systems, etc. And someone at some point with the correct access rights, sure, it's a bad practice, but they could do it, and they did it, opened a security group to the world. And so let me basically share a terminal here. The simple version of this was basically this. All right, we have a security group. We only allow SSH from the internal network, and we're good. What happened actually is, so let me go here, go to the VPC tab on AWS. So what happened in this case for this team is that since the pipeline was not being applied on a regular basis, security groups, all right, here. So here's our super secure security group. Let's change the rules, do something absolutely terrible, like enabling all traffic to anywhere, and call it BAMP for sure. Save. Now this super secure security group that you saw is not so much super secure. It's now open to the world. So if you are using Snyk IC, we have a describe command that is here to report you, for example, in this case, all the unmanaged resources. So I will probably have to authenticate. Is a good thing. I need also the OTP, which is also a good thing. All right. So in this case, Snyk IC describe will report you, will first scan your AWS account and report you in Terraform terms. So it's reporting, in this case, the real resource name and ID, etc., of things that are not under control. So in this case, it's globally under the VPC service, and more specifically, it's an AWS security group rule that has this ID. And now you know that your code coverage, who was 100% before this manual change, dropped to 85%. That's the type of information you get from the tool. You can specify specific provider versions. You can do a lot of things. We're going to explore this together with this live session. But basically, right now, that's what it does. If you have this IC describe thing in some cron job or whatever, you can even give it the most restricted access right you can find. We published an example with the least possible policy online. It's the opposite of what you would need with Terraform apply, because it needs a high level of accesses to deploy things. It's a deployment tool. This one is a reporting tool. So with the least possible access rights, that's the way it works. That's good. So in this case, now you know that a security group rule in Terraform terms with that ID was added somewhere. You're starting to have like really interesting information. And if you look at the written code, oh, that's one. So if you have this into any type of pipeline, recurring check, run job, whatever, it will send you a notification on Slack, by email, on PagerDuty or whatever. You can even have, we'll see that later, maybe security group rules are more important than S3 buckets, for example. So you can have with that tool, Snyk IC, you can have very specific checks in place for different types of severity. So what happens if you have actually Terraform apply every X hour for this case, for this example? What's going to happen is actually weird. We can see that in this case, it detected something, it reported it to you, but apply complete, resource, 0 added, 0 changed, 0 destroyed. Once again, it's okay. What it did, actually, it integrated that change to the Terraform state. If we look at the state and we look at probably 0, 0, yeah, we can see now that what we created manually is now integrated in a state. That's the way it works. No big deal. Problem is that no big deal. If you don't have a drift detection program in place, now no one else can discover that this thing happens, because you can Terraform apply and apply and apply. It will never revert this again. That's the way it works. So basically, this poor team spent quarters with an open port on the internet until someone completely inadvertently, by chance, discovered this. No one noticed it. That's an example of why drift detection is super important for us infrastructure developers, because it reports things in our context with, in this case, Terraform resources. That's not, the slides are not in the right order. I'm definitely sorry. So that was that was the security group story. The IAM story is even more frightening. We had a Lambda, and it was just reading stuff and just reporting somewhere else. So no big deal. During a weekend, overnight, production problem, and things were not working. People, the team on call at that moment was like, "Oh my God, what's happening?" And they were looking everywhere, and they wondered at some point, "Oh, maybe it's the Lambda." And the IAM user for the authentication, for the access key linked to this Lambda was read-only, so they tried different things. So the code for this, is it in main? Yeah, that's in main. So the code was mostly the simplified version of this. So we had an IAM user, very simple, with an environment. The access key was linked directly to this user entirely under control, and the policy that was attached was read-only. No big deal here. That's pretty standard, and that's supposed to work well. Actually, what happened is that they tried. So let me go to IAM. What they tried is, I need to log in again. Sorry. All right, that's the demo effect. That's good. Cool. So IAM. What the team did at that point was they wondered maybe it's a key problem. So they started by rotating the key here. So that's this user. And they said, all right, let's create a new key so we are sure, blah, 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 sure, never share this, sure we won't. Done. We have a new key. They worked around this, and no, it was not a problem with the key. So they said, oh, I'm sure it's the permission read-only, it's not enough. Let's do something. So I'm going to be extreme here, but let's add an administrative access policy to this poor IAM user that was supposed to be read-only, and it wasn't this as well. But remember, production issue, middle of the night, in the weekend. They continued, they kept looking for the solution, and finally, 2 hours later or something, they found a different solution, and they were happy. They went to bed, job done. It's cool. On Monday, we're gonna remember what happened, and we will fix what we changed. Guess what? Nobody remembered anything, but even if they did, what happens when you Terraform apply this? Once again, Terraform is a great tool, but it's a deployment tool. It's not supposed to know the things that are around what was described in this Terraform file here. So the user, the access key, and the policy. What it means is that we had Terraform plan every 5 minutes or something in a pipeline to report us changes, but the changes could not be seen. So in this case, if we had reason why we built Snyk IC describe, if we had Snyk IC describe on a cron job at this point, we would have this output, and we would have known immediately that something was very wrong. The IAM service has 2 unmanaged resources here. One is an access key with the ID, and the other one is an IAM policy attachment with administrative access. If you ask me, or if I receive this even in the middle of the night, I'm terribly worried, because it means that now we have an access key, a rogue access key, running somewhere with some people with some administrative access attached to it. Now we have a problem. Still, you keep the information of the IC coverage. You know that now we are only 66% compared to the 100% we started with. Still good to know. We're starting to have like multiple problems here, like the VPC is open to the world, the security group story is open to the world. We have a rogue access key and a policy attachment that is administrative access. That's bad. So that's it for this story. So having drift detection in place in this case is super important. You would have known immediately what was wrong, what was manually created, etc., and not needing anything else. Once again, we are infrastructure developers. We want that feedback in resource system. We want to fix this using our terminal and text editor. So this one was done. The S3 story is one with a team I was working with a while ago. It's incredibly fun. They were building something specific for them, and all the developers, something like 100 developers, were uploading continuously builds to S3, so QA could do the automated job with that. Means that like hundreds of gigabytes every hour were uploaded all the time. So obviously that team did not enable historical data for the buckets. At some point, this team had another team come fly to the UK and meet them and say, "Oh, we are in the process of securing all our buckets, etc., and we are activating this this feature that will create backups and historical data of all the objects in all the S3 buckets, etc." So the team I was working with was, "Oh, great! That's a good idea. There's dozens of S3 buckets, perfect for this, except one, the one I just told you about, the one about the QA and the hundreds of gigabytes uploaded every hour on it." So the other team was like, "Oh, thank you for telling us. We will obviously exclude this bucket from our project." They left, good friends. Everyone went back to their original countries, and a few weeks later, they launched the script to enable that setting on S3, and no one checked, obviously, hundreds of buckets. What happened is that there was a bug. The exclusion didn't work. So the loop didn't work. So this bucket actually archived all the changes day after day for a month, like until they received the AWS bill the next month, and they were like, oh, something is really wrong. So that was monitoring by billing service. They were very unhappy. So this is the simple version of the problem. Let's create an S3 bucket, and simple one. And then on edible, oh yeah, sure, I was logged out. Is it still working? Yes. So what they did here is basically the script, the API version of this, enabling versioning for the bucket. And they said, all right, let's do it. Guess what? That team actually had a recurring check, a recurring Terraform, not apply, but plan, or maybe they had apply. I don't remember exactly. But what happens when you do this? If you use only describe only unmanaged, this resource is managed, so it's not. Won't become an unmanaged resource just because you change a setting. So that's why we have a different switch on Snyk IC describe. So you can basically ask deeper inspection of different settings. So in this case, I'm asking the full account. We can restrict for a specific service or ID, but that would be cheating. For this demo, it takes more time because it has to request all the details from the APIs. Yeah, and in this case, we are like, all right, we actually have one managed resource. So this one that was from Terraform in the state, this specific bucket of this type, of this name, has something that changed. So that would be, once again, written code. One, if you have Snyk IC describe in a cron job, even once every 24 hours, the worst that can happen to you is that you will know about it in 24 hours. What that pool team had something like this, Terraform apply, in a similar check. And they thought, unfortunately, that it would revert any change. Guess what? Apply complete, resources, they are added, 0 changed, 0 destroyed. And the written code is 0. Once again, not a problem for Terraform. It's a deployment tool. The state is some way of exchanging information from the intention and the reality. Problem is here, it's that for us as infrastructure developers, if we want to know about things that changed, we need a different tool. That tool is Snyk IC describe for drift detection in this case. So that was the short version for the stories. To go, time is actually flying a little. To go to give a different example here, the usual simple case of someone created an EC2 instance using the wizard. It's that, yeah, if someone does create an AWS, an EC2 instance manually using the wizard, and you launch Snyk IC describe, you will get an output like this. You will know that the EC2 service has 2 types, AWS instance with that ID, with an EBS volume with that ID linked to it, and the VPC as well that was created with it. That's it's already great to have this information. Actually, you can know the different types of moving parts of your infrastructure that were manually created, that are not under control. That could be a huge security issue, but that's quite obvious, actually. So that's not the main problem. The other problem is that this person finished the test using their Amazon Linux on EC2, and they crashed. They terminated the instance. They're good. They think that it's okay. Now, it's actually not. The widget is what it is, a widget to help you do things easily and quickly to succeed in launching what you wanted to launch. In this case, if you just remove your EC2 instance, you still have a security group and a security group rule, two rules actually, in the while. It may not be a big deal, but remember a few slides ago, we said that maybe things that are not a big deal might actually be a big deal, because what happens if someone else in 3 months has to launch something and say, oh, I don't know, I don't want to create a new group, what's happening or whatever, and let's reuse that one here. There's widget written, that's probably good. Problem is, one of those rules allow SSH connection from the outside by default to everyone. You will never know about it as an infrastructure developer, sorry. So that's why having that type of information is super important. That's a very simple example on EC2. When we have more time, I play with it live. But it's exactly the same for many, many different services. And that's what widgets are for, to get you started easily. That's why we need drift detection inside a security product for developers to get that feedback, to help us integrate the changes, be notified of the changes in our terms, in Terraform terms in this case, so we can act quickly. So we showed only CLIs, CLI outputs until now. Pretty boring, but that's what our work as an infrastructure developer is. The reality is that most people have hundreds of drifts and managed resources, etc. When they get started, it's okay. But it gets very complicated, very hard to navigate the terminal. Plus, you can't share your terminal. So we observed people were like copy-pasting things, sending emails, creating Notion pages, wiki stuff, etc. So that was a mess. We created this HTML report to make things simpler to read. You can generate this one also to share that with your colleagues. Maybe you have someone to report the progress on the percentage of code coverage, for example. Maybe you have I don't know, some monthly challenge to remove all the VPC stuff that is not under control, etc. So that's the easy way to share and process the reports. Another thing this report does is you can select the state you want to take care of. So let's say you have 10 states, one for VPCs, one for S3, one for IAM, etc. Maybe you're not interested by having this big laundry list of resources. Maybe you want to take care only of the production state. Maybe you are interested only in the API gateway state. So you can easily select here just an IAC source, because Snyk IAC describe by default aggregates all the states it finds on Terraform Cloud, Enterprise, S3, locally, anywhere. So that's super powerful, both to build a complete view of the puzzle that composes your single AWS account, but that also creates a huge list of things that probably are not under control. So in this case, you can easily choose your state for what you are interested in. You have a searchable input box So you can say, oh, I'm just interested in things starting by, I don't know, secure, production, web. And the last thing you can do here is select a specific type. Maybe you are only interested in IAM users. You just want to know what IAM users are not under control or changed, etc. So that's what this HTML report does. We have good feedback from people, users, and customers putting the generation of this report into an S3 bucket, like every night. So with a dynamic name or something, up to you. So they can have an overview, some type of snapshot from a read-only tool that is very quick and generates a report of the state that day. They are happy to go back to it when something wrong happened later, and they can look at this report over time. Very different from having the local tool in the terminal for purely developers. That's really for sharing and longer-term storage. A very different, now we're back to something even geekier, the JSON output. The feedback we had was, oh, great, you have an output, but I can't do anything with it. Oh, you have an HTML report. Great, that's not what I want. I just want to process the output myself for my needs. So what we did is basically this JSON output, and that's super easy to process. It's a JSON structure. And the idea here is to be able to integrate this with your own scripts, your own processes, your own notification system, etc. We had a customer, like, I don't know, I don't remember, maybe it was last year or something, created a full dashboard integrated with their own monitoring dashboards internally for the IC, the infrastructure as code, the DevOps SRE team internally. And they were mainly graphing all the things here. So they integrated it basically in a time series database, and they graphed it, and they got alerts based on the variations of the numbers, etc. That's the type of things you can do here. One of the most obvious is graphing the code coverage for your IAC compared to the reality of your cloud account. Last but not least, filters. We have different ways of filtering the output, the drift output. In this case, so we are using GMS path to filter the queries and the reports. This, for us AWS infrastructure developers, is something we already know. That's the way it works on the AWS CLI. So that was our inspiration here. The idea here is to tailor the requests we do to our needs. So maybe we don't care about S3 buckets to be checked every hour or every day. Maybe it's only every month, I don't know. But maybe we are very interested by IAM users, security group rules, API gateway, stuff like this, and we want to filter specifically this in our cron jobs or reporting pipeline and stuff like this. So it was just a quick example here of how you can tailor this this product Snyk IC with the described tool integrated in it. So immediately, teams that care about the security of the cloud accounts from an IAC perspective can have the right feedback immediately. They know the type of the resource, they know the IDs, they know the names, they have the details. They can very, very quickly have the relevant information to actually act on this drift. I think I'm mostly done now. If you're interested by trying this, discovering Snyk, making it easy for you, we offer Snyk on the AWS Marketplace. So it's all centralized with the AWS Marketplace you already know and love. So it's working pretty well. It's easy, and you are on your own for buying this. It's super easy for you. And I highly encourage you to start detecting drift on your cloud accounts on AWS using Snyk. So you can create an account on Snyk.io. Most of the features are free on the free tier. You will get tired before you exhaust your free credits on a monthly basis. So try Snyk IC on Snyk.io. Talk to me if you want more information. And I think that's it. Thank you for attending. And now I'm happy to answer questions if we have questions.
Awesome. So thank you, Stefan. To our audience, send in your questions now, and we've got plenty of time to address them. So Stefan, let's take this one from the top. Does Snyk IAC support scanning infrastructure defined with AWS CDK?
The answer is not yet. The answer is definitely on the roadmap. It's definitely on the roadmap. We want to do it probably early next year, something like this. Speaking of CDK, it works with Terraform CDK, different type of CDK, because it can generate the code back to Terraform. So having just one more step, generating the code back to Terraform, can help us do that work. But no, AWS CDK doesn't work with a Terraform state at this point. But Snyk IC, just a product that detects misconfiguration, will work with some tweaks with much more tools than the drift detection does at the moment.
And we also had an attendee say, I assume the same with Pulumi.
So Pulumi is not supported at all. Unfortunately, it's at the very, very, very top of my PM product management list. That's a top request. We will take care of Pulumi very soon.
Wonderful. Stefan, I'm not seeing any more questions. So while we wait for any more to come in, I'm going to go ahead and give away a couple of gift cards.
Sure.
So these are for 4 $25 Amazon gift cards. Our 4 winners are Cindy B, Marcus G, Mauro D, and Juso N. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you do not happen to see that gift card, do check your spam folder. I'll also remind our audience that this session was recorded. So following this program, you should receive an email with a link to access that recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. All right, Stefan, I'm not seeing any more questions at this time. Just a lot of thanks for a great session. So I'll yield the floor to you one more time if you've got anything you'd like to close out with.
Well, probably what I said for 45 minutes. Take care of your cloud infrastructures. APIs are beautiful. Automating things is the basis of our jobs, but really knowing what's not under control is really, really important. We saw in all Foods examples how we can end up in a very, very bad place. So it's so easy to know about what's not under control. Yeah. So once again, try Snyk. It's a great product, and you have like a free tier that is very, very generous. So yeah, please try.
Great. Stefan, thank you. Thank you so much for joining us today and for really putting a lot of time into this presentation, and the demo as well. So thank you.
Thank you.
To AWS and Snyk, a huge shout out for sponsoring this program. We couldn't have had this program without both AWS and Snyk sponsorship. And to our audience, thank you so much for joining us. We appreciate you spending time with us. We do just ask for one extra moment of time for a survey that will pop up as soon as we close out. But otherwise, we hope to see everyone at an upcoming Techstrong learning program. Everyone, have a great rest of your day.